In this video, we're going to talk about function notation. So now we know what a function is. A function is any relation where when we plug in an x value, we only get one y value. So if we think about a function like a machine, it can help us to understand how to work with a function. So for example, I'm going to take this simple function y equals 2x plus 4 and just represent it in a different way. So we know that this is a function because it's a line. So a line has to be a function because it passes the vertical line test, and every time we plug in an x, we're only going to get one y. So we can think about this like as a machine. Here's our function, 2x plus 4. When I pop it at x, that x gets multiplied by 2 and then added by 4, and then it's going to pop out a y. So the x goes in, gets multiplied by 2 plus 4, and that's going to give us our y. So if we think about a function this way, what happens if I input a 3? So if I input a 3 here, so 3 is our x, it's going to get multiplied by 2 plus 4, and it's going to give us 10. So when we input a 3, we get a 10. Let's do the same thing for negative 2. We're going to take negative 2, input it into our function machine. It's going to get multiplied by 2, then plus 4, and we get 0. So our input is negative 2 and our output is 0. So when we know a relation is a function, we can write it in something called function notation. So we can take this line, which we already know is a function, and we can write it like this. So as you can see, this right side of the equation looks exactly the same. The difference is right here, this guy here. Instead of y, we have this f bracket x. In English, we say that that is called f at x. So that's what I'm saying, f at x. What it literally means is the function f. This is the name that we are calling this entire thing f. This is the name. We could call it anything else. We could call it g. We could call it whatever we want. In this case, we typically use f because f stands for function. So this is saying that the function f, that's what this guy is a function of x, which means that we input x, and that's what creates all our values for our functions. So we input our x, and out comes a value. So f, the function f, is a function of x. It moves with x. If all of that has just confused you, the most important thing is that when a relation is a function, we are allowed to replace y with f at x. Writing things in function notation can be helpful to show what you're doing. So let's use function notation and work out this example here. So this question says, if f at x is equal to 2x plus 4, find f at x when x is equal to 5. So if this is confusing for you, let's translate this. So this f at x, we can always replace it with y. If you're ever confused or f at x is confusing you, mixing you up, just change it to y and answer the problem. So every time I see an f at x, I'm going to change it to y. Eventually, you won't have to keep doing this, but just while you're learning, change it. So find f at x. What does that mean? Well, f at x just means y. So let's reread this problem after doing these changes. So if y equals 2x plus 4, find y when x is 5. Look how simple that problem is. Now it's so easy, right? All we have to do is put 5 in here, and what pops out for y. So what I'm going to challenge you to do is use function notation to find this. So now that we know what's happening, we're finding y when x is equal to 5. But our challenge in grade 11 is, can we do that using function notation? So I'm going to copy out the function using function notation, and then we are going to input x is equal to 5. So when we're inputting something into a function, we're going to, every time we see an x, we're going to replace it with 5. So we're going to write this first, f at 5 is equal to. So f at 5 means we're plugging 5 into the function machine. And let's see what pops out. So I'm going to copy the 2. I'm going to replace x with 5, just like we would have done in grade 9, and then plus 4. So I'm going to leave this as f at 5 on the left here. F at 5 is equal to 2 times 5 is 10 plus 4 is 14. And that's my final answer. So what does this mean? This means that when I plugged in a 5 into this function, I get 14. So we can also write this out as a point. So remember that f at x, this guy here, is just y, which means that this guy right here, we know is our x, and our answer is y. So we can write this out as a point as well. That means that the point 5, 14 must be on this line right here. Let's try another example. So here we're given two different functions. This function is named f, here it is, and this function is named g. You can call a function whatever you like. You can call it water bottle. It doesn't matter. In this case, we like to use single letters, and f is the most typical one, but it's not the only one. So it wants us to find the following. First, can we find f at 0.5? So what does this mean? F at 0.5 means that whatever's in here is our x value. So we're given x. X is 0.5. And if we're looking for f, the whole thing, f at 0.5, that must mean that we're looking for y. So we don't know what y is equal to. In this function here, if you need to change this to y, change it to y until it makes sense for you. So just rewriting that with y, does that look less intimidating? This is just a parabola. It's just a quadratic. And so this question is asking us to plug in 0.5 for x and tell us what y is. So I challenge you, use function notation. Don't use this guy here. So let's try it. So I'm going to start off with writing out the equation. So we have f at x is equal to 2x squared, plus 3x minus 1. And it's asking us to plug in 0.5 for x. Whatever is in this bracket is what we're to plug in for x. So here I go. So here's my function f. Instead of x, I'm going to plug in 0.5. And then I'm going to copy everything else. I'm going to change x to 0.5 everywhere I see it. Plus 3. Instead of x, I'm going to put 0.5. And then minus 1. So let's go ahead and throw that whole thing in the calculator and see what we get. I got 1. So what did we find? We found that when we plug in 0.5 into this function, we get 1. So can we translate that to a point? What point must exist on this function? So this guy we know is x. And the value we get at the end, so the value of the function is 1, so this one must be y. So the point 0.51 must be on this function right here. Another reminder, because someone will try to do this, this is not times, f times 0.5. So typically this would mean multiplication, but this notation, this function notation, means 0.5 into this function f. Let's try an example like this. This says we're looking for f at 3x. What does that mean? Well, let's start by writing out what f at x is. All right, so now let's figure out what is f at 3x. What does that mean? Well, we know here, this is the input. So if we think about back to that picture of a machine, we thought of a function as a machine. This is the thing that goes inside the machine. And we want to see what the output is. So this guy is going to be our new x. So every time I see an x, I'm going to put in 3x. And that is this goes for anything that goes in that brackets. This could be f of my hand, and every time I see an x, I'm going to put my hand. So every time we see an x, let's replace it with 3x. So here we go. So I'm going to start with f. The input is 3x. Every time I see an x, I'm going to replace it with 3x. So everything else stays the same. The 2 stays the same. Instead of x, I'm going to put 3x. And then we have squared plus 3. Instead of x, we're going to put 3x.
minus 1. So everything else stays the same. We are just changing the x's. So 3, 3, instead of x, we're putting 3x, then minus 1. And now let's just simplify. So I'm going to write, this is f of 3x, so 3x is our input. What does the rest of this thing look like? Well, 3x squared is going to be 3x times 3x, which is going to make 9x squared. So we have 9x squared plus 3 times 3x is going to be 9x minus 1. Let's simplify this one more time. And we will have 18x squared plus 9x minus 1. And we're done. There's nothing else that we can possibly simplify here. So f at 3x is equal to 18x squared plus 9x minus 1. Let's try another example. This one looks weird too. This is f of 2 minus 1. So remember what we just talked about. Anything in here, whatever that is the input. So this here is our new x. So let's go ahead and find it. First, I'm going to write out what f at x is. And now I'm going to replace x with 2 minus 1. So here we go. We're finding f of 2 minus 1, which is 2. Instead of x, we're going to put 2 minus 1 plus 3, 2 minus 1 minus 1. Here we go. Okay, so once we did this, we realized that we could have just simplified 2 minus 1 right away. Maybe you saw that. The textbook does this problem. I think it's a little bit silly, but I wanted to show you guys just so that when you see it in your homework, you understand it's actually really simple. So you could have just put an f at 1 right away, and you can see that it's going to be the exact same thing. So because all of these 2 minus 1s are going to just simplify to 1. Minus 1. Okay, so let's finish this off. So f at 1 is equal to 2 times 1, which is 2, plus 3 times 1, which is 3, minus 1. F at 1, or f at 2 minus 1, same thing, is going to be 4. So just a reminder of another way to think about what we just found is we know what the f function is. It's this guy here. It's just this parabola. So if we found that f at 1 is equal to 4, then we can also draw the conclusion, remember that this is x, and the value of the function, f, is just the same thing as y, what we called y before. So we know that the point 1, 4 is on this parabola here. Let's try one more example, algebraic example. So this is asking us for f at negative 1. We can do that. We've done that now 3 or 4 times. Plus g at 4. What does that mean? So remember that these letters just represent the name of a function. You can call a function anything you want. You can call it pencil case, you can call it hand sanitizer, whatever you want. This one's called f, this one's called g. So let's go back to the original question and we can see, oh, we were given 2 functions. We were given that f is equal to this guy here, and we were given that g is equal to this guy here. So let's write them both in our question, and then we'll figure out what we need to do next. Okay, so here's our f at x, here's our g at x, just copied from the top, from the original question. So it asks us for f at negative 1. Can we find that on our own? Yes. That just means that we're going to plug in x is equal to negative 1 into the function f. And can we find g at 4? Yes. All that means is that we are going to plug in 4 into our function that's called g. So you could work on this whole thing at one time. I like to work on them separately. So I'm just going to put a line here. I'm going to find f at negative 1 first. And then I'm going to find g at 4. And then I'm going to put it all together. If you have a different way to do it, as long as you get the same answer, not a problem. You want to work on them simultaneously. So in this function here, we're going to plug in our negative 1. Every time we see an x, and then we got minus 1, so let's finish this off. This is going to be 2 times 1 minus 3 minus 1. We're going to have 2 minus 3, it's negative 1 minus 1 is equal to negative 2. Okay, so here's our f at negative 1. Now let's find g at 4. So every time that I see an x, I'm going to plug in negative 4. Okay, so we've got g at 4 is equal to negative 3. 6 times negative 4 is going to be negative 24. So we have g at 4 is equal to negative 27. All right, now we just finished the problem up. This is asking us for f at -1, we have that, plus g at 4. So let's just replace what we know. So we're looking for f at -1, f at -1 plus g at 4. We know f at -1 is just -2, and g at 4 is just -27. So if we add that together, we get -29, and that's our final answer. Now that we know how to work with function notation algebraically, let's see if we can apply our knowledge to a graph. Okay, so you've learned absolutely everything you need to know about function notation. Now we're just going to review if you understand it. So here we're given this graph. It's of a parabola. We'll assume that there's just arrows at the end here. And it says use the following graph of the function f. So this guy is named f to determine the following. So we're not going to do any calculation. We're just going to use the graph here to check our understanding if we understand function notation. So I'm going to read out the questions, and then I want you to see if you can figure it on your own, and then come back to the video to check. So this one's asking for f at 2. Here's f. We're asking for f at 2. What does that mean? See if you can figure it out on your own, and then come back to the video. So pause it here, come back to the video when you've tried it. Okay, so if you're back, how can we find f at 2? We don't have an equation. Did you figure out if it's asking for f at 2 that this means that x is equal to 2? So if we are asking for f at 2, we're given x is equal to 2, and we're trying to find f. And what's another, we're trying to find the value of the function at x is equal to 2. And what's another way to say that? Well, then we're looking for y. So we don't know what x is, we do know what x is, it's 2, and we're looking for y. So let's use the graph. We don't need an equation to figure this out, we can just look at the graph. So here's where x is equal to 2, and right here is where is the point in which x is equal to 2, and we know that when x is 2, y is 4. So that must mean that the value of the function at 2 is 4, so our answer is 4. Try f at 0 on your own. Go for it. Pause the video, come back if you think you've got it.
Seeing the magic happen.
Okay, let's take this up. What does f at 0 mean? If we're given f at 0, it means that x is equal to 0, and we're trying to find the value of the function at x equal to 0, so we're looking for y. So let's go on to this parabola. Here is where x is equal to 0. And this is the point. When x is 0, y is also 0. So that means that the solution to f at 0 is 0, because the point 0, 0 is on the parabola. Just like here, the point 2, 4 is on the parabola. Let's try the last question. Here it's saying determine x when f at x is equal to 4. So here we're not given x, we're not given the input, we're given the output. So if we're given the output, then we know y. Y must be 4. And what is x is equal to? So let's take a look back at the parabola and see where x is equal to 4. So, y is equal to 4. Y is equal to 4 right here. So I'm just going to draw a dotted line. Here is where y is equal to 4. And we can see that y is equal to 4 in two different places of the parabola. Y is equal to 4 here and here. So what are our two x values? Well, we've got x can be equal to -2 or 2. So let's write that down. So x can be equal to -2 or x can be equal to 2. So there's two solutions here. So just to triple check, we're looking for x so that when we plug it in, we get 4. And if I plug in -2 into this function, I'm going to get 4. And if I plug in +2 into this function, I'm also going to get 4. Here's +2, 4, and we're done.